This is an interview of Mr. Isao Suzuki about the history of Hoya's glass substrate development. The advent of mobile computers in the 1990s required hard disk drives with much higher shock robustness than possible with aluminum-based media. Although it is counterintuitive, only glass-based media using chemically strengthened glass met the shock resistance and cost requirements of this application. From the outset, Hoya led the industry in developing and supplying such glass substrates. This oral history records the history of Hoya's contributions under the leadership of Mr. Isao Suzuki. Well, we'll start with the questions.
Okay.
Isao-san, could you give us your full name, where you were born, and where you grew up?
Okay. My name is Isao Suzuki. I was born in Tokyo and grew up in Tokyo.
What were the schools that you attended? What were your majors and areas of interest?
Okay. Tokyo Metropolitan University. I obtained the degree of Bachelor of Mechanical Engineering. The subject of my graduation thesis was related to the fatigue characteristic of aluminized iron alloy. The application of this material was for the engine valve of auto vehicle. This treatment improved the hardness and thermal resistance of iron alloy.
Could you summarize for us the companies you worked for, a brief description of your responsibilities and functions?
After I graduated from university, I joined Hoya. I joined Hoya in 1966 and continued to work in Hoya for 49 years, almost a half of a century. For the first 8 years in Hoya, I was in technical laboratory. I studied mechanical characteristic of optical glass, which is related to manufacturing optical lenses, especially grinding and lapping process. In 1974, I moved a new factory, which is located in Nagasaka, Yamanashi Prefecture. I moved to 違ったかなJust a wait, please.
Okay.
Okay. In 1974, I moved to a new factory, which is located in Nagasaka, Yamanashi Prefecture. The company decided to set up a new factory there for new product, that is hot mask blanks and substrate for the semiconductor industry. I introduced a new double-side polishing machine in the substrate process, which is of our own design, and a new polishing process with colloidal silica slurry as a slurry for glass polishing. Then I became a development manager for technology and new product in Nagasaka factory. I managed development in 4 fields. The first is precision machining technology. For example, that is master plate for optical disc, and laser component for laser fusion system. The second is thin film technology for optical thin film and yield display. And third is lithography technology, that is copy mask and the encoder. And the fourth is OE product, the optoelectronics products, like a laser oscillator, AOM, acoustic optic modulator, and so on. I started the development of magnetic disk with glass substrate from 1984. I moved to San Jose in 1986 in order to continue the development of media and set up a new process of media production with glass substrate. I returned to Japan in December 1988. From 1990, I was a general manager of MD division, whose products were media and substrate. After attaining over 60 years old, I supported MD division's business as a senior staff for technology and foreign affairs. I retired from Hoya last year in March of 2015.
MD stands for magnetic disk division?
Memory disk.
Oh, memory disk division.
Yes.
Thank you. Who were and what were your early influences at college or at work?
There were two big bosses. Dr. Izumitani. He was the top of technical laboratory of Hoya. He taught me strongly that you should study harder and experiments should be done to get some physical meaning. Then experimental result obtained should be checked from the viewpoint whether the result would be physically reasonable or not. He always studied so hard. Another big boss is Mr. Okutsu. He was an executive board director of Hoya. He was also the founder of the Nagasaka factory and business for electronics industry in Hoya. He insisted on the importance of the development manager. He said the company always need an excellent development leader. This leader should utilize researchers and engineers well. For it, the leader should have a clear vision of what he wants to do. Mr. Okutsu always said to me like that. I learned so many things from these two big bosses.
What is your current position?
I am entirely retired. However, I am still an honorary board member of IDEMA Japan and committee chairman for education.
When did Hoya start the data storage business, substrates as well as media?
Hoya started actual business of media from 1991. Substrate business was started from 1994.
So, why did Hoya decide to enter this market?
Okay, we started development for magnetic disk, magnetic media with glass substrate from 1984. At that time, we are looking for a new product without photomask blanks and OE products to expand electronics division's business. Maxter pushed us to provide a media with glass substrate. They requested a very smooth media. That was our first motivation to start the development of media. We already had very excellent process technology in substrate and sputtering process for the product requiring defect-free properties like photomask blanks. This is another reason we decided to start development of media. However, we don't have enough knowledge about HDD and media and head. We had to learn about head and media from first step. Several months later, after we starting development, we shipped media sample with glass substrate to Maxter for their evaluation. The first sample of media showed a good magnetic performance, low defect, low noise, low defect, even though these samples were made by experimental sputtering equipment. Maxter's request was something strange. They asked us to prepare a media with glass substrate without texturing and lubricant. Then we faced the stiction problem. It was not so easy to solve this problem. However, my top management decided to continue development in USA, nearby a potential customer. Hoya purchased the facility from Ampex in 1986. They are producing media with plating in this factory. We didn't have any interest on their plating equipment, but we could obtain a ZB1200 as a production sputter machine and much of testing equipment. Hoya established HEC there, Hoya Electronics Corporation there. In HEC, we tried several ways to solve the stiction problem. For example, mechanical texture, sputter texture, and so on. These development were done collaboratively with colleagues in Nagasaka. Though during this development, we could not realize a good process to avoid stiction stably. There were many important findings. At last, we are able to solve the stiction problem with SX code. A basic idea of SX code came from Nagasaka. HEC engineer refined this as stable process technology. Then we could get in the media market for HDD.
Who made the ZV1200 machine?
Diebold.
Thank you.
Diebold House.
Right. Glass is very fragile. Chemically strengthened glass is stronger. How difficult was it to persuade hard disk drive makers to use glass media to achieve shock robustness?
Yes, everybody knows, glass is hard but fragile. We prepared many data showing the toughness of chemically strengthened glass. And we prepared testing equipment for dropping glass repeatedly onto the floor. We demonstrated in the exhibitions like Disk 89 and others. However, no one worried about it after Toshiba succeeded in the 2.5-inch drive market. This is my feeling.
Why did Hoya select the pressed glass manufacturing method for the substrates?
Molding glass is one of Hoya's core technologies. This was applied for glassware and lens material for camera as Hoya's products. Hoya had already developed a 3D production system for a lens material. 3D means direct melt, direct press, and direct anneal. This system is very suitable for many types of glass production in one line. If required volume is limited, this system works very effectively. On the other hand, float process needs extremely huge volume. For small quantity product, float process does not work effectively and economically. Moreover, float glass cannot be applied for any type of glass. Glass composition is limited to apply this process. This is why we selected a pressed process for glass material production.
Did Hoya evaluate other glass manufacturing methods, such as down-draw glass?
Yes, we tried the fusion method. The substrate for a display panel is produced with this fusion method. At that time, Hoya had a joint venture company with NSG for the production of display substrate by fusion process. However, we gave up to use this process for disk substrate. Flatness was not good. The cost was getting higher to improve flatness.
Who were the key individuals responsible for implementing this strategy and plan?
Mr. Uchiya. He was an executive board director of Hoya Japan and a president of HEC. He decided to start the media development and move development activity to the US. Under his leadership, we could continue media development.
Did Hoya start by supplying substrates, or did it start by supplying media for the hard disk drive market?
That is media. We intended to enter in the HDD market with media from the beginning. When we started development of media, we didn't need any development for substrate. We had enough experience for the disk-shaped product, like optical disk. However, we could not expect any customer of glass substrate in HDD market at that time. We had to prove better media performance with glass substrate at first.
Who were the main customers for both media and later glass substrates in the early days of the business?
The first actual customer for media was Toshiba. We had supplied media sample to some HDD manufacturers, Ariel, and so on. The actual start of our business in HDD market was with Toshiba. It was in 1991. Then IBM followed. Seagate, Fujitsu tried to use Hoya media. IBM was the first customer for substrate. We started substrate supply to IBM from 1994.
What were the first HDD products that used Hoya media and Hoya substrates?
The first HDD that used Hoya media was Toshiba's 43 megabyte 2.5-inch drive with one platter. The name of drive was M40. The first HDD that used Hoya substrate was IBM's Wakasa 2.5-inch drive, which shipped in 1994.
Hoya's early media used a colloidal silica overcoat. I think you call it the SX process. Was it successful?
Yes. It showed excellent performance. We named this silica overcoat layer as SX coat. The layer was formed by a solid gel process with particles of colloidal silica. The magnetic layer should be spattered on smooth surface of glass substrate. Overcoat layer should have proper roughness to avoid friction with head. This was our concept of SX coat. Without this technology, I think Hoya could not get in HDD market.
Could you tell us how each of the product lines, substrates and media, evolved over time, and what percentage of each products made up the Hoya's business?
So in substrate process, basically we continue to use same type of equipment. On the other hand, we changed materials and operation conditions, which we are using in each step of process. For example, polishing slurry, polishing pad, chemical solution for washing, in order to meet customers' requirements. We try to modify something on production equipment, and at sometimes, especially when we expanded production capacity or set up new factory. After confirming the effectiveness of such modification in the new line, these modifications would be applied on equipment in existing lines gradually. For media process, we had to change the type of spatter machine in order to meet customer requirement on quality, performance, and cost. We started our media process with GB1200. We changed it to A400, M12, and finally an 11. These changes and or modifications in both process were usually done in the step of qualification for next generation product.
Hoya developed a special relationship with IBM for substrates and media. Could you describe how this came about and what its key aspects were and how it affected Hoya's business?
That was top-down decision. I suppose top management of Hoya worried we did not have wider technical base and enough knowledge for media and substrate business in HDD market. That was their concern for the future of MD business. Then they wished to establish a special relationship with IBM in order to compensate our weakness.
Okay.
Can I try again?
Yeah,
Sure.
どっからだっけな。Then they wish to establish a special relationship with IBM in order to compensate our weakness, because IBM was a giant in HDD industry. This is my suspicion. I think this decision was good. We could develop stable business relationship with IBM.
Who were Hoya's main competitors in this business during the early days and now?
NSG. NSG started media development at almost same time Hoya started. Maxter pushed them also. NSG and Konica Minolta have gone out of the business already. Ohara stopped their supply of crystallized glass material. Then only Asahi remains as a competitor for Hoya in the glass substrate market.
When did Hoya purchase NSG's glass substrate and media business?
In 2004, Hoya assimilated NSG's glass substrate activity for HDD application.
So we pick up the Hoya assimilated NSG's business. What were some of the challenges of integrating these two businesses?
Okay. NSG had established good discipline to control a local employee. We were able to understand their process well quickly after transfer. And we continue to use NSG material in their factory. Then this integration was done relatively smooth. However, we had to change and or modify some part of their process to Hoya's style in order to improve their productivity and profitability. And in order to improve their quality, we introduced Hoya's polishing machine and a washing line in their process.
What were the glass compositions that were used and why by both Hoya and NSG?
Hoya's material N5 is the aluminum silicate glass, especially designed for chemical strengthening. N5 has no alkaline earth. This glass can achieve a deeper and highly stressed compressive layer on the surface. NSG's material is also aluminum silicate, but contains alkaline earth. I suppose this glass composition is designed to meet the requirement for the float glass process.
What were the sizes of both the substrates and the media that have been produced?
1 inch, 2.5 inch, and 3.5 inch. Hoya produced mainly 2.5 inch for both substrate and media. 1 inch was for media, and 3.5 was for substrate. And for other size, like 0.85, 1.8, 54 millimeter size, these volumes were very limited.
Thank you.
And when we started, our development, when we started media development, the size was 1.25.
1.25.
Yeah, that's right.
Interesting. But was never commercialized. That size was never commercialized. How were the substrate and media developed? What were some of the challenges faced by the R&D team, by manufacturing? How were some of the problems solved? Can you give us some examples in those areas?
For substrate, in early stage, after starting our business in HDD market, we didn't know waviness and edge shape as important quality parameter for substrate. We understood these quality should be important to keep stable flying on head, stable flying of head on media. Fortunately, we had enough experience to reduce such a waviness and ski jump. We could meet the customer requirement at that time. However, smoother surface, lower micro waviness, and lower defect and contamination are always the parameters to be improved. Technology for media was changing so rapidly. I told SX Code already, this was a key technology for Hoya. We could enter into the HDD market with this overcoat. However, flying height reduction was progressing very fast, unexpectedly in 1990s. We could not continue to use SX Code. We had to change over coat material from SX to usual carbon in the second half of the 90s. Then we introduced a NX process to avoid stiction. This process was composed by the combination of polishing condition and etching action in cleaning process. We could obtain roughened surface on glass substrate with this process. Glass substrate, glass characteristic of N5 were compatible.
Compatible.
Okay, じゃあもう一回 repeat again.
Yeah, he can back up a little bit if he wants.
So we could obtain roughened surface on glass substrate with this process. Glass characteristic of N5 were compatible with this process. However, NX process needed tighter process control. That was another problem for production. Then HDD technology moved to lamp rod from CSS. That was lucky and good for Hoya.
Could you tell us in what form was a glass substrate sold in? As blanks or in a finished form ready to coat with the thin film layers? And could you give us a sense of the mix of those products?
We sold finished substrate ready to sputter at most 100%. We sold very limited volume as blanks to Toyo Kohan.
What were some of the challenges faced in selling the substrates with increasingly demanding defect requirements?
Substrate required continuous reduction of roughness, micro and nano waviness, and defect and contamination. These requirements became even more severe after perpendicular recording and DFH head were realized in HDD market. These improvements were done mainly in the process of polishing and cleaning. In polishing process, we try to optimize a type of polishing slurry and pad and process condition first separately and then in combination. In cleaning process, optimization in mechanical cleaning and selection of additive and chemicals in detergent were important. We continued this development for polishing slurry, polishing pad, and chemicals in detergent collaboratively with each supplier.
How important was the disc cleaning process for improving the quality of the substrates? What were some of the key innovations that Hoya contributed in this area?
Cleaning process is very important to remove particles and organic residues attached on surfaces of the substrate during the polishing process. In this process, a certain kind of chemical will be added for etching the glass surface slightly. This etching action with a chemical solution is very effective to remove particles. But glass surface is roughened by this etching action. The type of chemicals should be selected carefully. A mechanical cleaning with a scrub machine is used jointly in this process. A lot of know-how is accumulated in this process.
The users, I think, of substrates started to demand automatic optical inspection at some point. Can you recall some of the challenges to implement this, and how was it solved?
We are using, AOI at 100% for final inspection in substrate production right now. Hoya used AOI at first in the substrate process for photomask blanks from early 1980s. This AOI was developed by Hitachi Deco. And for magnetic disk, we are developing a fully automated substrate production line in Nagasaka with limited volume in the second half of 1980s. In this trial production line, we investigated to introduce AOI with Hitachi Deco. Then we didn't have any concern for checking on a transparent disk with their AOI. Our concern was cost, because their AOI was so expensive. So detectability, throughput, and stable operation rate were challenges to introduce AOI in our production. Hitachi Deco improved their system to meet our requirement. Most important benefit by introducing this system was that reliability of inspection result was improved. By this stable inspection result with AOI, we could understand properly the effect of improvement actions which were taken in a process. Then we could achieve high and stable production yield in each factory. Okay.
Do you use an optical surface analyzer as well?
Yes, yes. OSA is used practically for DFA.
Where were the substrates and media manufactured?
Substrates were manufactured in Nagasaki, Japan at first. Then Thailand, the Philippines, Vietnam, and Shenzhen, China. The Shenzhen and Philippines factories had been closed. Media were manufactured in San Jose, US at first, then Nagasaki and Singapore. The media activities in Hoya were transferred to WD in 2010.
How did Hoya organize this business in Japan, in Singapore, and in Thailand?
That was in Japan. At present, a headquarters of MD division is in Vietnam.
Which were the principal operations and locations for R&D?
R&D for substrate process was done in Japan, in Nagasaki and Akishima.
And who were Hoya's main customers, both in the past and now?
Toshiba, IBM, Fujitsu, Seagate, WD. Currently, Seagate, HGST, WD, Showa Denko, and Fuji Denki.
There was a technology transition from contact start-stop, also known as CSS, to ramp load-unload in the early 90s. Did it influence the introduction and development of glass substrates? If so, how?
Yeah, it depends on customer. So IBM adapted ramp load unload fast in the HDD market. In another HDD manufacturer, they still continue to use CSS in their drive over middle of 90s. Then we faced the section problem again, as I told you previously. Anyway, this transition was good for glass media and substrate because it made free from the concern of stiction.
Can you describe examples of the best successes as well as the worst failures?
After starting business, expansion of production capacity for substrate and media was too slow. We tried to increase our production capacity in Japan and overseas, but timing was too late. Expansion speed did not meet to increasing demand from customers. We were in panic. We could not supply enough volume required for every customer in that time frame of middle 90s. That was my fault. I should get approval for investment to expand production capacity from top management much earlier. Hoya accomplished overseas production successfully. I think that was the best for Hoya's MD business. Especially Vietnam factory was successful. We put our experience obtained in operation of Thailand factory and set up newest equipment in each process of Vietnam factory. Then Vietnam factory could ramp up smoothly and became the leader factory on the point of quality, production yield, and cost. The management of MD division could lead these three factories, Thailand, Philippines, and Vietnam, compete and collaborate with each other in order to improve the quality, yield, and cost.
Can you give us a sense what is the worldwide market for glass substrate measured in units, and what is Hoya's share?
As you know, shipping volume of HDD is decreasing year by year. Then substrate shipping volume also decreased. Current shipping volume of Hoya substrate will be around 65% of peak volume, which was achieved in 2012. According to the newest trend forecast, Hoya's substrate shipping volume in CQ1 2016 was 75 million pieces per quarter. That is 25 million per month. Hoya's share was 93% in glass market and 34% in the total market, including aluminum substrate.
Did the industry ever succeed in developing alternative competitive solutions to glass substrates?
In the past, there were topics on new material for substrate, like composite material, silicon carbide, and silicon crystal. I didn't hear any such topics currently.
The media industry started to use increasingly higher temperatures for longitudinal media, reaching as high as 250 degrees centigrade. Were there special challenges to adapt the glass substrates to the higher temperatures?
Yeah. Glass transition temperature, TG, of current material is 504 degrees centigrade. Then a glass substrate has enough heat resistance for a current media process. Hoya prepared 3 kinds of new material for hammer application, which TG is ranging from 675 degrees centigrade to 740 degrees centigrade. These substrates are being evaluated by customers.
Was there any impact to glass composition or processing when the industry switched to perpendicular magnetic recording?
Glass type itself was the same, but customer requirement for substrate quality was getting more severe.
What were the challenges of developing substrates applicable for hammer media? And are they ready from a viewpoint of technology and manufacturability?
Heat resistance of substrate should be improved for hammer application. Hoya already proposed 3 types of substrate to customer for hammer, which were applicable on volume production. These are now being evaluated by customers.
What do you think was the key to Hoya's longevity and success in the substrate business?
I think Hoya was lucky. As I told you, we had a hard time in early stage of our business, but we could expand production capacity timely to meet market demand after that. Overseas operation was one of important key. We could realize low cost and huge volume production in overseas operations. The Vietnam factory was very successful. We could lead 3 factories located in Thailand, Philippines, and Vietnam to compete with each other for improvement on cost, yield, and quality, and at that same time to collaborate with each other for these improvements. The quality of Hoya's substrate would be good. To keep a good quality always was another key for our continuing business in HDD market.
How many substrates did Hoya produce since its inception as a business, and how many drives were made using Hoya substrates?
I am not sure, but I guess Hoya produced more than 4 billion pieces of substrate, and these substrates were used in more than 2.5 billion units of drive.
What is Hoya's outlook for the future of hard disk drives, as well as substrates and disks?
Market environment for HDD is changing. Not PC market is shrinking. On the other hand, high storage capacity HDD is expected because data that should be stored is predicted to increase explosively in the future. The HDD industry will change to meet such demand change in the market. Hoya is willing to contribute to such change in the HDD industry.
Well, this is the end of my questions. Are there any other subjects that you would like to
Thank you very much.
talk about or discuss?
Thank you very much.
I want to thank you for the opportunity to be able to do this interview. And I want to congratulate you on the exceptional success that Hoya had in this business. And I'm sure it could not have happened as well without your leadership. Thank you very much.
Thank you very much.